of the following sequence. 1 plus 9 over 10 plus 9 over 10 squared plus 9 over 10 cubed plus so. Solution. So the first term here is equal to 1. So now, to find the common ratio equal to the second term divided by the first term. And the second term is 9 over 10. So divided by first term, which is 1 over 1. So r is equal to 9 over 10 multiplied by 1 over 1. So r is equal to 9 over 10. And sum of infinity is equal to a over 1 minus r. We have done a video on that, so I will leave the link in the description box. Now here, we are going to substitute those values there. So sum of infinity is equal to, wherever we see a, we are going to put 1 over 1 minus, wherever we see r, we are going to put 9 over 10. So let's simplify 1 minus 9 over 10. 1 minus 9 over 10, so this also over 1 is equal to, the LCM is equal to 10. How many 1 can we get in 10? 10. Minus, how many 10 can we get in 10? 1. 1 times 9, 9. So is equal to 1 over 10. So sum of infinity will now be equal to 1 over 1 over 10. That is inverse of 1 over 10. So the answer is equal to 10. So the sum of infinity is equal to 10. Okay, you see, it's very simple. So let's solve another example. 2. The sum of the first 3 terms of a GP is half its sum to infinity. Find the positive common ratio. So here, the first thing that we need to do here is that we have to write the sum of the first 3 terms of GP. And since they say that it's sum of infinity, it means that r is less than 1. So here, sum of first term of GP will be equal to, Sn is equal to, when r is less than 1, will be equal to a into bracket 1 minus r raised power n over 1 minus r. And here is 3. So n is equal to 3. Anywhere we see n, we are going to put 3. So s of 3 will now be equal to a into bracket 1 minus r cubed over 1 minus r. Now, so this s subscript 3 is equal to half of its sum of infinity. And sum of infinity is equal to a over 1 minus r. So now, s subscript 3 is equal to half of sum of infinity. So let's substitute their values there. So let's call this one equation 1 and call this one equation 2. So substituting equation 1 and equation 2 into equation 3 gives substituting equations 1 and 2 into equation 3 gives the following. So equal to a into bracket 1 minus r cubed over 1 minus r is equal to 1 over 2 multiplied by a into bracket 1 minus r. So simplifying this equation gives a into bracket 1 minus r cubed over 1 minus r is equal to a over 2 into bracket 1 minus r. Now multiply both sides by 1 minus r. So multiplying both sides by 1 minus r gives the following. Now a into brackets 1 minus r cubed over 1 minus r multiplied by 1 minus r is equal to a into bracket 2 into bracket 1 minus r multiplied by 1 minus r. So this 1 minus r cancel 1 minus r. 1 minus r here cancel 1 minus r. So we are left with a into bracket 1 minus r cubed is equal to a over 2. So here also, this is over 1. So we can still multiply both sides, divide both sides by a. So dividing both sides by a, the following is obtained. So be equal to a into bracket 1 minus r cubed divided by a is equal to a over 2 divided by a. So a cancel a cancel a. So we are left with 1 minus r cubed is equal to 1 over 2. So from here, we want to make r cubed the subject of the formula. So you can say 1 minus 1 over 2 is equal to, so if this negative r cubed, if it goes out, it becomes positive r cubed. So r cubed is equal to 1 minus half gives 1 over 2. So taking square roots of both sides, gives the following. So cube root of r cubed is equal to cube root of 1 over 2. 1 over 2. So cube root of r cubed is equal to r is equal to cube root of 1 over 2. So that is the common ratio. The first term of a geometrical progression is twice its common ratio. Find the sum of the first two terms of the progression if the sum to infinity is 8. Now, suppose the first term is small letter a. First term is equal to a and the common ratio is equal to small letter r. And according to this question, a is equal to 2 multiplied by r, equation 1. Now, find these first two terms of the progression if its sum to infinity is 8. So, sum to infinity is equal to a over 1 minus r. So, and is equal to 8. 1 minus r is equal to 8 over 1. So, here is equation 2. Wherever we see a, we are going to put 2r. 2r is equal to 1 minus r is equal to 8 over 1. So, cross multiplying gives 8 multiplied by 1 minus r is equal to 2r. So, we can divide both sides by 8. 1 minus r is equal to 2r over 8. So here we have 2, cancel 2, 1, 2 here, 4. So 1 minus r is equal to r over 4. So we can still cross multiply. So 4 multiplied by 1 minus r is equal to r. So let's expand. We have 4 minus 4r is equal to r. So from here, 4 is equal to r plus 4r. So 4 is equal to 5r. So let's make r the subject of the formula by dividing both sides by 5. So 5 cancel 5, we have r to be equal to 4 over 5. R is equal to 4 over 5. And recall that a is equal to 2 multiplied by r. That is our equation 1. So here, wherever we see r, we are going to put 4 over 5. So 2 multiplied by 4 over 5 is equal to 8 over 5. That means the first term is equal to 8 over 5. Now, to find the sum of the first two terms. So that means n is equal to 2. And since r is less than 1, so the formula will be equal to s subscript 2 is equal to a into bracket 1 minus r squared over 1 minus r. 1 minus r. So s subscript 2 will be equal to, anywhere we see a, we are going to put 8 over 5 into bracket 1 minus r is equal to 4 over 5. Then we square it, cover everything over 1 minus 4 over 5. So let's simplify. We have 8 over 5 into bracket 1 over 1 minus 16 over 25, everything over. The LCM of 1 and 5 is equal to 5. So how many 1 can we get in 5? 5. 5 times 1, 5. How many 5 can we get in 5? 1. 1 times 4, 4. So s subscript 2 is equal to 8 over 5. So LCM of 1 and 25 is 25. 1 in 25, 25. 25 times 1, 25. Minus 25 in 25, 1. 1 times 16, 16. Over it, everything over. 5 minus 4 here is equal to 1, everything over 5. So this one is equal to 8 over 5 into brackets. 25 minus 16, 9. 9 over 25 divided by, okay, let me do that one, over 1 over 5. So s subscript 2 is equal to 8 times 9, 72. 5 times 25, 125. So divided by 1 over 5. So s subscript 2 is equal to 72 over 125 multiplied by 5 over 1. So 5 here 1, 5 here 2. So it remains 2, 5 here 5. So the answer is equal to 72 divided by 25. So how many 25 can we get in 72? That is 2. So the sum of the first two terms of this GP will now be equal to 2 whole number 22 over 25. Very, very simple. So thank you for today's class. Thank you very much for joining me. So till I see you in the next class, thank you and God bless you.